Hey class, this video is going to help with estimating a population. So the first section we talked about biased population samples, and some of them are a little confusing and you have to think about whether they were biased or unbiased. So we're still kind of going with that same kind of topic. But this section, the second section, is talking more about estimating a population. How would you estimate it? So here's my first example from the book. Let's see. Maybe. Okay, so the number of orange golf balls in the population is proportional to the number of orange golf balls in the representative sample. So what was that word proportional? What did that mean again? Well, that meant a fraction that's equal. So here's our first example. If the population had the same kind of, well, we don't know how many are in the population, right? But the representative, we have 2 orange to a total of 1, 2, 3, 4, 5, 6 in this sample population. So that's a fraction of 2/6. We would assume this one has that same fraction of 2/6 or 1/3 as it was reduced. So we could figure out a third of 150 and estimate how many are in the population here. So they show like there are about 1/3 of 150. So let me move this down a little bit. 1/3 of 150. So if you think of the word of and you want 1/3 of something, it means to times. What is 1/3 of 150? Well, it's the same as breaking it into 3 pieces, right? Because you want 1 of the third if it was in thirds. So you're going to basically take the 150 and you're going to divide it by 3 to get 50 for the population. So what did I do again? I took a sample, a representation. I used that idea of a proportional relationship to find about how many are in the population. Is this ever going to be exact? Well, no. So it's always a guess. It's never going to be exact, but close. I mean, your answers are going to be exact because they give you specific, different things for specific questions. I'm not saying what I meant to say because I'm too busy looking at my next example. Let's look at this question here. Suppose it is 200 years in the future. The population consists of humans and robots. You collect a representative sample. If the population has 13,500 members, estimate the number of robots in that population. Well, what do we know about this population here? Well, we know there are 2 robots, right? 1, 2, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 2 robots of the 10, right? So that's going to be our constant of proportionality. It's going to be that 2 to 10. So then we can figure out our total numbers. So if I think about, let me find a piece of paper real quick. So if I think about that, so I have that relationship is 2 robots to the total, right? And that's going to reduce to a fifth. And I want to know how many out of the 13,500. So I would take the 13,000, that looks like a B, 13,500, and I would times it by that 1/5 or divide it by 5. I'm going to steal my calculator. So 13,500 divided by 5 or times 1/5 is going to equal 27,000, right? And so there's the idea is there is going to be about 2,700 or 2,700 robots in a population of 13,500. So again, we used a sample. How many are in that sample? We reduced that fraction and we times it by the total to find the number of robots for that one. You might also see some graphs where they show the constant of proportionality and the number of, it doesn't matter what they're talking about, the sample size and the number a four-leaf clovers in each one in the sample size. So they are showing some different constant proportionality. Let's see. So this one, I didn't really want to walk through that one. Now I'm like, well, I should because now I'm talking different. Well, I was going to do a different one, but now I'm going to do this one just because I showed part of it. So a botanist wants to find the number of four-leaf clovers in a field. There are 700 clovers in the field. She has 3 samples of the population. If the actual number of four-leaf clovers in the field is 6, which sample best represents that population? So we're deciding which of these 3 samples best represents the population. So this first sample, A, oops, is way up here, has 1 four-leaf clover, and it has 1, 2, 3, 4, 5 total. So this is 1 to 5, right? And it only has a sample of 5. That's it. That's pretty small. The bigger your sample size, the more accurate your data is typically going to be. So B, whoop, has a bunch. C even has more. So let's just look at the numbers. There is actually 25 numbers in B, and there is 100 in C, and there's only 1 four-leaf clover in all of the above. So this first sample's constant of proportionality is 1/5. The second one's 1/25th, and the third one is 1/100th. So they say there are 6 out of 700 total. Okay, so there were 6 clovers out of 7, or four-leaf clovers out of 700 total. So we have to decide or compare the fractions. Which one's closest to 6 over 700? So one way is to divide 6 by 700 and look at the decimal. This one is going to be about, so I'm going to use squiggly lines, 0.00857, whatever. So there's the actual that they gave us. And then let's look at those 3 samples. A was 1/5, B was 1/25th, and C was 1/100th. Let's find which decimal is the closest to this one. Well, what is 1 divided by 5? Well, that's 0.2. And this is equals 0.2 because it's not an estimation. 1 divided by 25 is going to give us exactly 0.04. 1 divided by 100 is going to give us 0.01. 1/100th, right? Which one of these is the closest to the actual? Well, 0.2 is way more than this, right? If we round this would be 0.01, which is the same as C. So C is the best representation compared to the actual for the sample. What do we notice about that? Well, we notice that sample C had the most in their sample size. All right, so that's how I could compare like 3 samples. I'm going to actually, and against an actual. I think that's pretty much the best. I think that's going to answer the questions the most, I guess, for this one. All right, let me know if you have more questions.